Swift Scholars, I hope you are ready for a particularly animated video lesson as we work through animations. This is the second and last video in our UIVieWAnimate app as we lead up to Bip the Guy. The first video covered setting up a very simple UI that we use to discuss the iOS coordinate system, moving items around, the view controller lifecycle, and we offered some tips as well as some quirks to look out for. Now in this video, we'll cover how to animate objects in motion over time. We'll look at the alpha property to make objects fade in and out. We'll animate color changes and fade through the rainbow. And we'll work with all sorts of animation properties, including duration, delay, options, including those related to the animation timing curve, repeat and auto reverse, and we'll build spring and bounce effects with spring damping and initial spring velocity. And we'll use code in our very last challenge to begin Bip the Guy in the next video. Let's spring into action! Now, if you work through our Word Garden app, you've already seen animations using UIView transition. So UIView.animate should seem familiar to you, but it's got even more options for us. So the version that we're going to use shows up like this in code completion. It's got just two parameters, with duration and the animation parameter. And the way that we'll code it is like this. You specify how long your animation will take. That's what goes into with duration. That's a number in seconds. And then you specify the end state for your animation, where you want things to end up. And you put that single statement or a group of statements inside of curlies. iOS takes care of the rest. Want to move the clown head up 200 points? Just subtract 200 from imageview.frame.origin.y inside of the curlies in your animation block. And if the with duration parameter is set to 1 second, you'll see the clown waft up and arrive at that destination being animated by iOS over the course of 1 second. So since I've given you the syntax and you've already worked with animation properties through closures in our Word Garden app, why don't we do our first animation as a challenge? When the move button is pressed, animate the image view that has the clown in it from the location off screen to the center location on screen. So the same movement we had before, but this time use an animation and take 1 second to do it. Now here's how the animation function should be written. You just need to put in the code to modify this to do exactly what you want. Another hint, just like we learned in Word Garden, any class properties or methods in a closure that includes what's inside the curly braces for our animation attribute need to have self dot in front of them. And as a bonus, if you get just the image view to move over, why don't you try to move everything except for the move button over as well. So pause, give this a try, and let's take a look at the solution. So I'll write my animation right in move pressed. If you type UIView.animate, you'll see a bunch of different options in there, and I'm going to select this one that has with duration and animations. We'll explore these other options later, but this is the one we want, so press return. The duration is going to be 1 second, so that's just 1.0. Now remember, the animations parameter is the end state that we're going to get to. It's a statement or a set of statements that are inside of curly braces. That's called a closure. Now, just so that you know, I could type curly braces in here and put the end state of my animation in between these curly braces, but instead I'm going to double click on the blue highlighted area after the animation label, and Xcode will automatically format this in what's called the trailing closure format. Now, this statement up here is the traditional approach. It's not the trailing closure. It has the last parameter in the function separated out by a comma. The closure is preceded by a label animations with a colon, and the closure finishes off with a closing parenthesis. But most developers prefer this syntax here. So Swift lets you surround the parameters that aren't in the closure. Remember, the closure is the stuff in the curlies, ending the statement off with a parenthesis, and then the closure comes after the closing parenthesis that's in the set of curlies. It doesn't have a label out front. It's just listed here at the end of the statement. Now, they both do the same thing. More often than not, you're going to see developers use the trailing closure format. It's a little bit nicer to break out any extra lines of code so that they're not bundled in with the other parameters of the function call, and you don't have the ending with a curly brace and a parenthesis too. Either way, they both do the same thing. Make sure that you can recognize them both. So again, double clicking on the animation parameter gets rid of the animation label and it creates the trailing closure. And we've already got our end state. This is where we want things to end up after the animation. This line down here that takes the image view center point and moves it to the center X. So I'm going to highlight this, cut it out with a Command X, paste it in between the curlies of the animation. Now this is almost what I need, but if I build and run, I'm going to get an error here. Can you guess what the problem is? I'd warned you about this. We need to add self dot in front of image view and in front of view because both of those are class properties. So I'll click fix, it adds self in front of image view, and it looks like I don't get a fix for this, but I'll just type self in front of view.center.x. Now let's build and run and see how this works. Click move. Our three buttons jump right over because those aren't animated. We're just changing the coordinate, but look at that clown waft over, super creepy, and it takes 1 second to do so. That's animations, super easy. Let's get those buttons to waft over too. Now, being a closure, that doesn't mean we could just add one statement. We could add multiple statements. So I'm going to press return inside of my closure after I set my ImageView.center.x to give myself a little bit more room. Then I'm going to highlight my 3 other statements down here, cut them out with a Command X, paste them inside of my closure, and oops, I clicked build and run too soon. I need to put self in front of all of the class-wide property values. Now we can build and run. Click that move button. They all move over together. Nice. Next up, we're going to code the alpha button. Now, alpha is a graphics term for the level of transparency of an item. So in iOS, the alpha of 1.0 is fully opaque, not at all transparent, and alpha of 0.0 is fully transparent. It's invisible. Now, every iOS item that's descended from a UI view, so everything that you can see on the interface builder, has an alpha property, and we can change that. So let's write our code to make our clown fade away over the course of 1 second by animating its alpha property. So this is going to be super easy. Right here inside of alpha pressed, we will add a line that says UIView.animate. We'll choose the option with duration and animations. Our duration is going to be 1 second, so 1.0. And I'll double click this blue area in the animations parameter to get the trailing closure format that I like so much. And we'll say self.imageview.alpha equals 0.0. So it's 1.0, fully opaque by default. Over the course of 1 second, we'll get that creepy clown to disappear. Build and run. Click move, the elements slide over. Click alpha, clown be gone. Over the course of 1 second, you get this beautiful fade out. Nice. Now, if you click alpha again, our code is executing, but it's just transitioning from a start state of alpha 0 to an end state of alpha 0, so no animation is going to show there at all. Let's make this toggle. We can do that with 1 line of code using the ternary operator. So inside my closure, I'm going to get rid of setting it to 0.0. I'm going to put in parentheses. I'm going to copy self.imageview.alpha, and I'm going to construct my ternary operator this way. I'll paste that into the parentheses, say equal 1. So if my alpha is equal to 1, if it's true, then after the question mark, I'm going to set it to 0.0. Otherwise, if it's not equal to 1, it must be equal to 0. So I'll say colon 1.0. And by the way, if you option click on top of alpha, we can see that that property says get and set. Get means we could read from the property. Set means we could write to the property. And that's exactly what we're doing here. We're getting it when we check to see if it equals 1.0. We're setting it on the left-hand side of the equal sign where we take the result of the ternary operator. Now let's build and run and see if this toggles. Click move. Everything moves over. Let's click alpha. Clown be gone. Click alpha. Clown come back. Click alpha. Clown be gone. Nice. The toggle's working great. Now let's see about changing colors, and the way that we'll do that is we'll create 2 properties at the top of our class. So let's first create an array called colors. We'll say let colors colon, and then in brackets UI color, that's the type that this array is going to contain, equals, and then inside of brackets we'll put in as close to Roy G. Biv as we can get, dot red, comma, dot orange, comma, dot yellow, comma, dot green, comma, dot blue, comma, dot system indigo, comma, dot purple. So not quite Roy G. Biv, Roy G. B. So I guess it's as good as we can do. Apple, we need you to put a violet in there. And we'll create a color index to keep track of which index value we're on, and we'll increment this each time we click on the button until we get to the end, and then we'll restart at 0. So we'll say var color index equals 0 for starters. And you know what? This colors array doesn't need to be a class-wide property, so I'm going to highlight it, cut it, and paste it into my color change press function. So now what I'm going to do in color changed press is every time you click this button, I'm going to take the color change button and I'm going to change that to the next color, fading that in over half a second. So let's choose our animation function, UIView.animate. We'll choose the one with the duration and with the animation closure. Press return. Duration is 0.5. Animations always start with open and close curlies, and in between those, inside we'll say self.colorChangeButton.background color equals, and that's going to be colors, and then in brackets it'll be color index. And then we also want to increment that color index value after we've changed the button. We could do it inside the closure, but we'll do it down below, outside of the UIView_animate statement. Color index plus equals 1, that increments it by 1, and then we'll put an if statement after if color index equals colors.count, open and close curlies, color index equals 0. So if we've reached the end of all of our colors, we go back to the beginning. And because you're super swifty, you might be wondering, I wonder if I could take that if statement and turn it into a ternary operator statement. And the answer is yes, you can. We could simply say color index equals, and then in parentheses, we'll do our comparison first. Color index plus 1, that's the value we're trying to see if we should go to, equals colors.count. Question mark. If it does equal the end of the array colors.count, then we want to go back to 0, so we'll put 0 in here. Otherwise, colon, if it's false, we'll take color index and add 1 to it with a +1. So I'm going to comment out these 4 lines of code because I've replaced them with this 1 line of code. Let's build and run. Oh, error, I should have paid attention. So our color index is a class property. I didn't include self dot in front of it. There we go, that's better. Error goes away. Now build and run. Click on move. The items waft over from the right. Moment of truth, click change color. First color is red, orange, yellow, green, blue, indigo, purple, back to red. Nice, you are painting the rainbow. Can we still alpha toggle? We can. You are animating swifter. Now let's experiment with some of the additional options that are inside of this animate method that we haven't used yet. So up here in my move press method, underneath my current animation, I'm going to replace this with an animation that I'm writing down below. I'll say UIView.animate. Now you can scroll up and down and see the different options. The one that I want you to choose is the one that I've highlighted here, where code completion says animate changes in one or more view using the specified duration, delay, options, and completion handler. Press return. So for our duration, we'll put in 2.0. For delay, for starters, we'll put 0.0, so no delay. Now you can have 0 or more options. Options are entered array style between square brackets. We'll enter the brackets but leave them empty for now. For animations, we'll do our open and close curly. Then I'm going to highlight and copy this first line in my previous animation closure, self.imageview.center.x equals center x. Paste it in between my animation closure down below. And for completion, we don't have any. It's okay to type nil in there. And so let's experiment with delay. I'm going to copy the line that I just created, paste it down 3 times below, and I'm going to change my width duration and my delay parameter so that each one gets progressively faster, but it starts progressively later. The first copy will have a duration of 1.5 and a delay of 0.5, then 1.0 and 1.0, and the last one will be 0.5 with a delay of 1.5. Now let's change the name of the value that we're animating here. The second one will be alpha button, the third one pulse button, the fourth one color change button. I can delete this call to UIView_animate above. I'm replacing that. Now let's build and run. Here we go. Moment of truth. Click move, and we're off to the races. Look at that. The image view starts right away. The other 3 are progressively delayed half a second each, and each one also has a duration that's faster by half a second. That's why they all arrive at their destination at the same time, so we know how to use UIView_animate with duration in combination with delay. Cool. That can be a nice effect if you want to delight users by having different items animate over on screen when they use your app. Next, let's work with some of the options that you could use in this options parameter. So I'm going to show you how we can change the timing of the animation curve. By default, animations use what's called the curve in and out. That means they start slow, speed up, and then slow down before ending. Now to see all the different options for changing this animation curve timing, let's set all 4 animations to a duration of 2.0 and a delay of 0.0, so no delay. Now if we click in between the square brackets for our options parameter, we could use dot notation, type dot, to expose all of the different options we could use. Feel free to experiment with these things on your own. We're going to start out first by selecting this option, curve linear, for our first animation. Notice what code completion says. A linear animation curve causes an animation to occur evenly over its duration. That just means its animation speed stays the same. So let's press return and accept this. By the way, if you're going to use the options parameter, you have to include a delay in there, even if your delay is going to be 0, but you can get rid of the completion handler. Then I'll add 3 more transitions in here. And those go in between the square brackets, which is an array in the options parameter. So the alpha button will use dot curve ease in. That starts slow but ends at full speed. Pulse button will use dot curve ease out. That starts at full speed but slows down at the end. And color change button will use dot curve ease in out. Starts slow, ramps up to full speed, and then just before ending slows down again. And by the way, curve ease in out is the default option, so if I didn't have any options in here, this is how the timing curve would behave. And again, it doesn't matter if you have the completion handler in here. So I've built and run. Watch what happens when I click on move. All the items are actually going to end at the exact same time. That's after 2 seconds, but you'll see them moving with different timing curves. That's exactly what we see here. You can build and run again. If you really want to prove to yourself that they're arriving at the same time, you can dramatically increase the duration so that you can see the items move slower. But another thing that we could do is we can use repeat and auto reverse options. So let me show you how we do that. I'll return to our code, and in our first animation statement for the image view, inside the square brackets for our options, after my dot curve linear, I'm going to say comma and then dot repeat. That will, as code completion says here, repeat the animation indefinitely. Then I'm going to copy the comma dot repeat and I'm going to paste it into all of the other options for for my other 3 animations. Let's build and run and take a look. And we can count how long it takes all of the objects to line up on the left-hand side. 2 seconds, 2 seconds, 2 seconds, over and over again. The animation repeats with all 4 items always arriving at the same time. Cool. I've got another option for you, auto reverse. So let's go down and in our options for our pulse button, let's do a comma after repeat and say dot auto reverse. And we can see code completion tells us that this runs an animation backwards and forwards. Now you must combine this with the repeat option, but we've already got dot repeat as part of our options array. Now I'm going to highlight comma dot auto reverse, copy it, also paste it in as an option on my last animation. That's the one for the color change button. Now let's build and run. Click move, and everything is repeating, but the last 2 are auto-reversing, going back and forth. Cool. Now I'm going to return to my code, and I'm going to highlight 4 my animation statements in move pressed, copy these lines with a Command-C, and Command/ to comment them out. Then just above the block I commented out, I'll paste in what I'd copied, and in the first animation statement in this block, I'm going to change my width duration attribute to 0.5, and I'm going to delete the delay and the options parameters. Then I'll copy this first line and paste it 3 times below. And you know what? I'll delete the other 3 lines that are below this. And I'll set the next 3 interface objects to alpha button, pulse button, and color change button. So you can build and run here if you want just to verify that things are working. But what I've essentially done is set things up so they move all 4 items at the same time and take just half a second to do that. Now we've got our color button to change colors. Let's get our pulse button to pulse. And the way that we're going to do this is we'll record the button's original frame, and then we'll shrink the button on all sides. So we'll do that first shrinking before the animation, so it will instantly get smaller, but then we'll right away animate it back to its original size. Now that animation alone is going to make the button look like it's growing, but then we'll learn how to use 2 iOS physics effects on our animation. One is using spring damping, and the other is initial spring velocity. Now once we tweak those numbers, we're going to be able to make the animation look like a springy pulse, good for the punching effect that we want to use in the Bip the Guy app. Now to shrink the button, the plan is to move the left and right sides of the button in by 30 points and the top and bottom in by 10 points. So this is how we're going to shrink the frame. We're going to add 30 points to X. Now remember what that does is that actually moves the whole button to the right 30 points. But to actually shrink the button, we're going to have to subtract those 30 points from the width for one side and then another 30 points for the other side. So we'll take 30, multiply it by 2, and then subtract that from the width. Same with the height. If we want to move the button down by 10 so that we start the top of the button 10 points below where it currently is, we're going to have to add 10 points, but then we're going to have to subtract from the height 10 points representing moving in from the top and 10 points representing moving up from the bottom. So let's code this up. Inside of our pulse pressed function, the first thing we want to do is we want to save the original frame before we shrink the frame. So we'll create a constant let original frame equals, and we can say sender because remember we're trying to shrink the button that was clicked, and the button that was clicked is passed into this function as sender dot frame. Now that's the frame we'll be returning to in the animation. Then we'll create 2 constants. The first represents how much we're going to shrink the width on each side. So we'll say let width shrink equals 30, but one catch, we need to specify the type here. Now Swift automatically assumes any number without a decimal is an int, any number with a decimal is a double. We don't want to be either of those, we want to be a CG float, so we're going to declare this as a CG float. So we declare the type right after width shrink with colon CG float. Then below that, the constant we're shrinking the height by will be let height shrink colon CG float equals 10. Then we're going to create a new CG rect. That's a new rectangle, and we're eventually going to assign that to the sender. The sender is the button, so that's going to shrink the size of the button. And since this new smaller rect is going to shrink the frame from its original size, we'll call this smaller frame. So we'll say let smaller frame equals. Now this is of type CG rect, open parenthesis. You got a lot of different choices here. The one we want to select is the one with X, Y, width, and height that are all CG floats, so select that and press return. Just to make this easier for you to read, I'm going to put each of these different parameters for CG rect on different lines. And for X, we want to add width shrink to X, so we say sender.frame.origin.x plus width shrink. Then for our width, we want to say sender.frame.width and subtract 2 times width shrink. And it's pretty much the same thing for the Y and height, so for Y, we'll say sender.frame.origin.y plus height shrink, and height will be sender.frame.height minus 2 times height shrink.
And now that we created the rect that's going to be the smaller frame for our button, we'll instantly shrink that button to the smaller frame before we animate it. And we can do that by saying sender.frame equals smaller frame. So the button is instantly shrunk.
And then we're ready to animate. We'll say UIView.animate. We'll choose the option with duration in animations. Duration will be 0.5. Our animations are always in between curly braces, and we'll say this is going to be sender.frame equals original frame. Then we'll build and run. This won't be the bouncing effect. We click move to get our buttons to move over, and then when we click on pulse, you can see the button immediately shrinks and then grows over the course of half a second. Cool, but not really what we want. Let's add some bounciness. Now watch this other tip in Xcode. So I want to add a property to this function called using spring with damping. Now as I start to try to type it right after with duration, I see code completion isn't recognizing it. And the reason for that is even if I'm not going to use a delay, we need to have a delay parameter in there in order to use using spring with damping. So I'm going to say right after the comma in 0.5 for my duration, I'll say delay colon 0.0 and then comma. And as I start to type in using spring with damping, I can see it shows up in code completion. It's listed as an argument name, so that's recognized as an argument for this function. Press return, and we'll set the using spring with damping value to 0.2, then comma, then we'll add another argument name. That's going to be initial spring velocity. Again, it shows up in code completion.
Press return.
And we'll set that value to 10.0. Now over in Apple's documentation, we can find out more about using spring with damping and the initial spring velocity. And the way that you read this is you can see to the right, it refers to the damping ratio and the velocity as two values that are being passed in to these two arguments. If we look down below, we can see both of them are mentioned. Now for damping ratio, the second paragraph is most descriptive. It says to smoothly decelerate the animation without oscillation, use a value of 1, employ a damping ratio closer to 0 to increase oscillation. We set ours to 0.2. That gives it an extra bit of bounciness. Now, as far as velocity is concerned, below that we see a value of 1 corresponds to the total animation distance traversed in 1 second. For example, if a total animation distance is 200 points, and you want the start of the animation to match the view velocity of 10 points per second, use a value of 0.5. Now we set our velocity to 10, which means that original spring is going to happen super fast. So we're extra fast and extra springy. Feel free to experiment with these values on your own, but let's go back to the code and build and run and check out the bounciness. Here we go. Let's click that pulse button. Boom, 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 boom. That looks fantastic. That looks like you're bipping the button. That brings us to our final challenge. To set up what we're going to need for our Bip the Guy app, what you should do is in the UIView Animations project, modify pulse pressed so that the image view pulses. Set the duration to 0.25 seconds. Inset the frame of the image view, 20 points on each side. That means shrink the frame, 20 points on each side, and then pulse outward. Why don't you pause, give this a shot, and let's take a look at a solution. So our code for the image view is going to be almost identical to the code that we have for our button. First, we'll create a constant to hold the original frame. We'll say let original image frame equals imageview.frame. Then let's create our width and height shrink constants. We'll say let image width shrink equals 20, and then let image height shrink equals 20. Then we'll create this smaller rect that we're initially going to shrink our image to, and we'll do that with let smaller image frame equals CG rect. We want to select the option with the X, Y, width, and height that are all CG floats. I forgot to declare the image width shrink and the image height shrink as CG float, so we'll do that now with a colon CG float after each constant name. And to make the initialization of the CG rect easier to read, I'm just going to put my X, Y, width, and height on separate lines. And for the X, we'll say imageview.frame.origin.x plus image width shrink. And then the width is going to be imageview.frame.width minus imageview.shrink times 2. Our Y value is going to be imageview.frame.origin.y plus image height shrink, and our height is going to be imageview.frame.height minus image height shrink times 2. Now we're ready for our animation, so we could say UIView.animate.
I'm going to choose this option with duration and animations, but I'm going to make sure that I've got all of the parameters in here.
Time interval is going to be 0.25.
I need to add a delay parameter, so I'll type that in, comma, delay, colon, 0.0, and I'll double click the animation parameter to get the trailing closure format I like so much.
Then we need to grab the two values that handle the springiness, and I'm just going to grab those out of the UIView animate that I wrote above. I'm going to go up here and I'm going to highlight my using spring with damping through my initial spring velocity.
I'll copy those two arguments with the two values.
Then I'm going to paste those both in after my delay. I'll keep the use spring with damping value to 0.2 and the initial spring velocity to 10.0. That looked good before. And the end state in the closure that's my animation is going to be self.imageview.frame equals original frame, but I need to make sure just above my UIView.animate that I set imageview.frame equal to smaller image frame. And Xcode gives me another warning up here in yellow. These warnings can be so helpful to you as a developer. Take a look at this. Can you see what I did? A hint, you can't see it in here, but it says initialization of immutable value, original image frame was never used. Down below here in the animation, I referred to original frame when I should have referred to original image frame. So I already copied original image frame above. I'm just going to paste it over original frame. Now, if I just do a quick Shift Command K,
that's the shortcut to clean the build folder.
Essentially what it does is it has Xcode recalculate the connections between all of the values. This is a really good thing to do if code completion isn't recognizing a newly declared variable or constant, but it'll also look for any errors and warnings, and if there are outstanding warnings like this one that are no longer valid, they'll just go away. Sweet, we're ready to build and run. Hammer time! Build succeeded. Let's click on move. Everything wafts over. Looking good. Let's click on pulse. Whoa! Take that, clown! Bip! Bip! That looks magnificent. Swifter, you've essentially learned how to animate the image that we're going to use in Bip the Guy. We'll start that up in the next video. Why am I so animated? Because you've got mad animation skills. Keep at it.